Hello viewers, you're welcome to this channel Medical Science Lecture Room. Here we try to keep our viewers informed on science and medical matters. Specifically, we take our viewers on chemistry, physics and mathematics tutorial. And also, we educate or teach our viewers on medical issues. In case you're new to this channel, please hit the subscription button. Also turn on your notification bell so that when new videos are made, you'll be first to be notified. Share and like the video. For today, we'll continue with our lecture series on mathematics, and the topic will be on polynomial. Let's begin. Polynomial expression is a mathematical expression formed by the sum of two or more terms, with each term having a numerical coefficient and possibly a variable raised to a positive whole number. This definition is very important, and I would like to take it again. A polynomial is a mathematical expression formed by the sum of two or more terms, with each term having a numerical coefficient and possibly a variable raised to a positive whole number. I would like to explain every aspect of this definition because this forms the basis of the topic polynomial. So for you to have understanding of this topic, there has to be understanding of this definition. Now, I began by telling you that a polynomial is an expression and it must have two or more terms. Now, the word sum was used, which means addition. So, if I have, for instance, f of x equal to 3x cubed plus 5x squared. Let's take this. If I say this is a polynomial, I want to use this to explain why we say this is a polynomial. Now, we said a polynomial is an expression that has two or more terms. You can see that before this plus sign, we have 3x cubed, and after this plus sign, we have 5x squared. I want you to understand that any of these that you see appearing before a plus sign or a minus sign, that refers to what? A term. Now, it means that in a polynomial, you will have two or more of these, and each of them, we were told that must have what we call a numerical coefficient. A coefficient in mathematics, of course, you know, refers to a number or something that stands in front of what? A variable. In other words, a number that stands in front of a variable. Now, if I say 5x, let's say 5a, now you can see that the a is in front of this, the 5 is in front of the a. It tells you that this 5 refers to what? The coefficient of what? A, where the a is what? The variable. Now, with respect to this, it means that this x is a variable. The variable in this context refers to what? The unknowns. In other words, letters. In most cases in mathematics, we use letters to refer to variables. So we are saying that in every term must have what? A variable, and every term must have what? A numerical what? Coefficient. Now, I have told you what a coefficient is. That a numerical coefficient is a number that stands in front of what? A variable. As you can see here, 3x raised to power 3 tells you that 3 here is a numerical coefficient because 3 stands in front of what? The x, where the x is what? A variable. Now we have, from that definition, we said that there has to be two or more terms. For this, we have this is a term because it comes before the plus sign. This is a term because it comes after the plus sign. If I decide to say minus 10 x raised to power 4, if I decide to say minus 10x, again, this is what? A term. This comes after the minus sign. So whatever you have that comes before the plus sign or after the plus sign, or before a minus sign or after a minus sign, these are all referred to as what? Terms. They are all referred to as terms. Again, we said that each of these must have what? A number that stands in front of it, and that is what we refer to as numerical coefficient. Now, for the first one here, this is the first term. What do we see? 3 is in front of what? The x, where the x is a variable. For the second one, this is the second term. What is in front of this x? Square. You see that the x square has what? 5 in front of it. Therefore, 5 is what? The numerical coefficient. Now, how about the third term? The third term has minus 10 in front of the x. Therefore, minus 10 in this case refers to as the coefficient. So, you can see that each of these has a numerical coefficient. Each of them has what? A variable. And this variable can be x, it can be y, it can be any letter. Now, we also saw that from that definition, we were told that each of these terms must have a numerical coefficient. Each of them must have a variable, and the variable must be raised to a positive whole number. What do you see? For this first term, the variable is x, and it's raised to a power 3. For the second term, the variable again is x, and it's raised to power 2. You can see for the third term, the variable is x, and it's raised to a power of what? 1. Now, there is none of them that is raised to what? A negative power. So, if I have something like this, you will not say this is a polynomial, because the power of this variable is what? Minus. We said for it to be a polynomial, the power of the variable must be what? A positive power. Now, there is a positive power of 3, there is a positive power of 2, there is a positive power of 1, which is why this fits into what? The definition I have given you as what? The definition of what? A polynomial. Very, very important. Now, having understood what a polynomial is, the next thing we have to discuss is what we call the degree of a polynomial. The next thing we have to discuss is the degree of a polynomial. The degree of a polynomial. Now, I want you to know that when you have a polynomial like this one refers to what? The first term. For this, for instance, based on what I have written on the board, this is 3x squared cubed refers to the first term. This has to be the second term. This is what? The third term. Now, this tells you this is a function. This means a function of x. What that means is that what the component of this expression are all defined in terms of what? X. So if this was y, then we should have here 3y cubed, 5y squared. So, but in this case, when you see x here, it tells you that this expression, this function is defined in terms of what? X. Now, the degree of a polynomial. Please, it's easy. The degree of a polynomial can be defined as the power to which the variable is raised to. So, if I'm looking at what? The degree of the term of a polynomial, there is difference between the degree of a polynomial and the degree of a term of a polynomial. Now, when we are looking for the degree of the term of a polynomial, we are simply looking at the power of the variable of that term. Now, if, for instance, if I want to get the degree of the first term, remember the first term is this one, and the power of the variable is what? 3. Therefore, the degree is what? 3. If I'm looking for the degree of the second term, then it has to be T2 equal to, I will ask myself, what is the power of the second term? The power of the second term is 2. You can now see that the degree of the second term will be what? 2. If I'm looking for the degree of the third term, what is the third term? The third term is what? Minus 10x raised to power 1. Now, what is the power of this x? It's 1. Therefore, the degree of T3, which is the third term, is 1. So, the degree simply refers to the power. The degree of the term of a polynomial refers to the power of the variable of that term in request. That very term you're interested in, the variable that is there, the power of that variable will give you what the degree of the term of the term of the polynomial. But again, what if you're asked what is the degree of the polynomial? Remember, there is a difference between the degree of a term of a polynomial and the degree of a polynomial. Now, if I want to get the degree of this polynomial, it therefore has to be the highest power. The highest power. Now, from here, you can see now the degree, you can say the degree of f of x. is equal to, the highest power is what? 3. Because if you check, here the power is 1, is 3, here the power is 2, here the power is 1. In other words, the degree of the first term is 3, the degree of the second term is 2, the degree of the third term is 1. But the degree of the entire polynomial has to be the highest power. Please take note, has to be the highest power. And in this case, the highest power is 3. That's why we say the degree of this polynomial is 3. So that's very important. So the degree of a term of a polynomial is simply the highest power of that expression. So let's take, supposing we have another example. What if we have f of y is equal to, f of y is equal to 10 y raised to power 10 minus 5x raised to power 8 plus 3x raised to power 7 minus x raised to power 8. Minus x raised to power, let's say 6. So we want to get the degree of each of the term of this expression. Now you can see that degree now. We are looking for the degrees. For the first term, the degree of the first term, of course, you know, for the first term we have, the first term is 10 y raised to power 10. What is the power of the variable? The variable in this case is letter y. This is the y letter. Now the power is simply 10. Therefore, the degree of the first term will be what? 10. For the second term, the degree will be what? Sorry, because this is f of y, here has to be what? All through here will be y. Please take note. Because the expression is defined in terms of what? Letter y, f of y. Therefore, every of the variables must be what? Y. So we have the second term, the power of what? The y is 8. Therefore, this will be what? 8, the degree. Now for the third term, T3, the power is 7. Therefore, this will be 7. For the fourth term, the power of the fourth term is what? 6. And so that will be the degree. And now when we are looking for the degree of the expression, the entire expression, what is the degree of the entire expression? We say it has to be the highest power. Which of the powers here that is the highest? Of course, you know it's 10. Therefore, 10 becomes the degree of what? The entire expression. Now let's take another one. Supposing we have f of x equal to 2x y x raised to power 3 y raised to power 2 plus now suppose this is another example. Now we want to find out the degree of each of these, of each of the terms. Now, see the difference between this one and this. This is defined as f of xy. That means the component of the variables in that expression are x and y. As you can see, xy, xy, xy. Y this is f of y, meaning that the variables must all be what? Y. As you can see, all through we have only letter y in all the terms. Now for this one, the terms must have the variable xy because the expression is defined in terms of what? Xy. Now we want to know what the degree is for each of them. This is the first term. We will now say T1, the first term. Please, in this case, because we have two types of variables, two different variables, and each of the variable has each of the variable has powers. So what you do is to add the powers together. So we're going to say 3 plus 2. For the first term, T1 is the first term. The variables are x and y. What are their powers? 3, 2. So we need to add the powers together, and that will be what? Equal to what? 5. For the second term, what do we see? X and 4. X is 4, y is 3. So this will be what? 4 plus 3, and that will be what? 7. For the third term, what do we see? 5 and 4. The power of the x is 5. So that will be 5 plus 4, and so that will be what? 9. Now we can now say, therefore, the degree of the expression. Please take note, in exams, they may just say, what is the degree of this? If they just say, what is the degree of this expression, of this, it means they are asking for the highest power. But if they say, what is the degree of the third term? Of course, this is the third term. the answer will be what? 7. If they say what is the degree of the, or if they say what is the degree of the third term, this is the third term, sorry, the third term, the answer will be what? 9. If they say what is the degree of the second term, this will be the answer, 7, 4 plus 3. But when they say what is the degree of this expression, again, that will tell you that you are to look for what? The highest power. And what is the highest power? The highest power is 9. Therefore, the degree of this expression f of xy equal to 2x cubed y squared plus x raised to the power 4y cubed minus 5x raised to the power 5y raised to the power 4. The degree has to be what? 9. So that's how to get the degree of what? A polynomial. It can either be in this form or it can be in this form. Please take note. Now let's quickly look at the addition and subtraction of polynomial. I need you to understand, viewers, you to have a perfect understanding of polynomial and to be able as a student to solve every problem that comes from polynomial as a topic. Then you need to have understanding of all these subtopics of our polynomial. But for this video, I'll be taking what? Addition, subtraction of polynomial, and perhaps multiplication of polynomial. Then some other videos, you check for them, like I told you, I've said, check for other video, you will see there is a video for division, there is a video for remainder theory, for factorization, and so on. So let's look at addition and subtraction of one polynomials. So we have the following question to address right now. Now, remember, I told you that this video will be focused on addition, subtraction, and multiplication of polynomial. I have other subsequent videos for division of polynomial, for also remainder theory and factorization of polynomial. These are all what you should know for the topic polynomial, if you must attend every examination question that has to do with polynomial. Now look at this, the questions we have on the board. Now we've been given first polynomial. We were told that F1 here in this case tells us that the first polynomial is given as this, the second polynomial is given as this, F3 is given like this, and then this is F4. And remember that each of them, they are all defined in terms of what? X. What that means is that whatever variable that you have in each of the expression must be what? X. And now they went further to tell us that for question number 1, or A, we should look for F1 plus F2 minus F3. This simply tells us that F1 and F2 should be added together, and then the answer should be used to subtract what? F3. That's what that means. Then for B, they've asked us to use the polynomial 3, the third polynomial, to subtract the second polynomial and then add to what? The fourth polynomial. And the same thing for the C option, question 3. The question 3 requests that we should find F3 minus F2 plus F4. Of course, that's the question. There's a B question. Whatever we have here, we should multiply with what? The polynomial 4, the fourth polynomial. So let's quickly address it. Solution. We'll start by saying solution. Now for this is simply a formula, more or less a formula. So we say that for A is F1x plus F2x minus F3. We have to follow that formula. This is more or less a formula. What is F1? F1 is 2x raised to the power 5 minus x raised to the power 4 plus 3 x raised to the power 3 minus 2 x raised to the power 2. Now this is what I have written here represent F1, because they say F1 plus F2. So my F1 is 2x raised to the power 5 minus x raised to the power 4 plus 3x raised to the power 3 minus 2x raised to the power 2. Then plus, that's the plus sign. The next is what? The second expression, which is what? F2. We bring it forward. This is 4x raised to 4x minus x raised to the power 2 plus 3x raised to the power 3 plus x raised to the power 4. In other words, F2, this is the whole of this represent what? F2, where F2 is 4x minus x raised to the power 2 plus 3x raised to the power 3 plus x raised to the power 4. Then the next is what? We're asked to minus. We're asked to minus F3. So we're going to have a minus here. And what is the F3? Is x raised to the power 3 minus 2x raised to the power 4 plus 5x raised to the power 5. Sorry, 5 raised to the power 5. So this represents F3, where F3 is x cubed minus 2x raised to the power 4 plus 5x raised to the power 5. So we have follow the formula. The formula just said F1 plus F2 minus F3. And that's what we have done. All of this represent F1, all of this represent what? F2, all of this represent F3. Remember, there is a plus sign. Therefore, we had a plus sign here. Remember, there is a minus sign. There is a minus sign here. So we'll continue. Now, at this point, remember that this minus sign is subtracting everything here. For that reason, there has to be what? A bracket there. Because a minus sign, of course, once you use a minus sign to subtract anything, it will change whatever you are subtracting it, you're subtracting it from. So there has to be a bracket there. If I decide to put a bracket here, a bracket here, of course, you know, plus multiplying the content of that bracket will remain the same thing. That's why I didn't want to put a bracket. Or you can put, but it doesn't change anything. Now, so this is what we have there. This is where we are. Now from here, we will now see how we can remove this bracket. Let's see how we can remove the bracket. And so at this point, I will bring down this one, which is 2x raised to the power 5 minus x raised to the power 4 plus 3x raised to the power 3 minus 2x raised to the power 2. This is it. I didn't do anything to it. I had to bring it down. Then the next thing is plus. This is a plus because, like I told you, there's supposed to be a plus, a bracket here. Now, if I'm to remove this bracket enclosed F2, so that plus, this plus, multiplying everything in this bracket, it will remain this. That's to say, plus times 4x, it will give us plus 4x. Plus times this will give us minus x squared. This plus times this will give us plus 3x raised to the power 3. This plus times this will give us plus x raised to the power 4. You can see that the plus will not change anything. Whatever that is here, when you multiply it with plus, it remains the same thing. Now, but when we now use minus, this minus is to multiply everything here because we want to remove the bracket. Now we now say minus. Remember that this thing is supposed to be this way. Minus times this x cubed. That will give us minus x cubed. Minus times this. Minus times minus, of course, will be plus. That will give us plus 2x raised to the power 4. Then again, minus times plus 5x raised to the power 5. That will give us minus 5x raised to the power 5. It is very, very important for every viewer or student to be very attentive whenever you're multiplying these signs, because once you do not represent, you misrepresent any of this sign, then the final answer won't be correct. So I go through it again. Minus times x raised to the power 3. Remember that the x raised to the power 3 here has a positive invisible sign. There is a plus sign here. That plus times the minus will give us what? Minus x raised to the power 3. We don't need to bring in a bracket again, because using this to multiply the content here means you want to remove the bracket. So there is no need to indicate the minus sign, the bracket again. So minus times x cubed will give us minus x cubed. Minus times minus 2x raised to the power 4 will give us plus, because anytime a minus multiply a minus, it turns to what? A plus. So minus times this will give us minus times this will give us plus 2x raised to the power 4. Minus times plus, because anytime a minus multiplies a plus, the answer will be what? A minus. Therefore, minus times plus, that will give us minus. That's why we are having a minus 5x raised to the power 5. Now, at this point, this is where we are. Now, remember, we need to make this thing concise. So what do we do next? Please, people, my viewers, what you need to do at this time is to select light terms. When we are selecting light terms here, we are looking at those variables with the same powers. When we are selecting light terms, we are looking at the variables with the same powers. We bring them close together. And now, we bring them close. And now, if you are doing that, remember again that the way this expression were given, you notice that there was a specific order. Now look at the power here was decreasing. 5, 4, 3, 2. That means there is a decreasing power. That is what we call descending order of degrees. If you look at this, one, the powers are what? Increasing. The powers are increasing. This is ascending order of increasing degrees. So it means that whatever you have as your final answer must also either be in ascending order or descending order. You don't, arrange them in such a manner that there is no specific one order. Now, if I want my answer to be in descending order, that means my arrangement of like terms, I will begin with the highest, the one that has the highest power. If I want my answer to be in ascending order, it means that my arrangement of like terms, I will begin with the term with the lowest word power. Now, I want my answer to be in descending order of word powers, descending order of degrees. It means I should start with the term with the highest power. Now, I need to ask myself, all through, I'll go through this is where we are. All through, which of these has the highest power? You've seen that we have x raised to the power 5 here. You've seen that we have x raised to the power 5 here. So these are the two with the highest power. I will bring them out. I'll bring them together. So I will take this one first. This will be what? 2x raised to the power 5. I'll bring this one. Remember, when you're bringing them down, you bring them alongside their sign. Their sign refers to the sign in front of them. Now, like this one, 2x raised to the power 5, there is a plus sign here. This plus sign belongs to the first term. Therefore, I have brought it down with a plus sign. Because it's the first, I don't need to put plus here. Even if you put a plus, nobody marks you wrong. But it doesn't matter. Even if I place it without the sign, every mathematics student understand that there is a plus sign there. It's only when it's a minus we must indicate a minus. Now, this is 2x raised to the power 5. I'll now bring the other one. This one has a minus sign. Because the minus sign is in front, I'll bring it. And this will be minus 5x raised to the power 5. In this case, you see that minus, you bring it, this minus belongs to this term. Please take note. This minus belongs to this 5. Now, these are the two with the highest power. If you go through, there is none with power 5. There is none with power 6. That's why we started with power 5. And there is none. These are the only two with the highest power of 5. Now, after this, which of the terms, again, that has a power less? After 5 is 4. Look at it. We have 4 here. So we bring this one down. Of course, this x raised to the power 4 has a minus sign in front. So I will bring it down with its own minus sign. That will become minus x raised to the power 4. I will go through again. Where do we have 4x raised to the power 4 again? This is where we have it here. And of course, this one has a plus sign. I'll bring it with its plus sign, plus x raised to the power 4. Where do we have it again? Where there is another x raised to the power 4 here. I'll bring that one with its sign. The sign is plus. This will be plus 2x raised to the power 4. You can see that 3 of the terms have the power of what 4. And these are minus x to the power 4 plus x to the power 4, then plus 2x to the power 4. Now, after power 4, the next is power 3. Now, you go through again. There is power 3 here. We bring it down. That is plus 3x to the power 3. Again, where do we have power 3 again? This is where we have it again. This is plus 3x to the power 3. After that, there is minus x to the power 3 here. And that's all. Now, after this is power 2. Power 2. There is power 2 here. That is minus 2x to the power 2. Look at it. Then we have another power 2 here. Minus x to the power 2. Where else? We have another. There is none. These are the only two that have power 2. Then after that is power 1. The one with the variable with the power 1. This is it. Plus 4x. Plus 4x. Do we have another? If you go through, I think that's all. Now let's see if we have actually represented the required number of terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have actually picked all of them and we've arranged in order of what? We have arranged in order of what? Descending order of degrees, and also with like terms put together. So at this point, you will now say, okay, what do we do next? What do we do next? Because this and this have the same word. The variable is x raised to the power 5. We can possibly say, if you like, sometimes you may want to factorize. If you want to factorize, what is common between this and this? Is it not x5? You say x raised to the power 5 into 2 minus 5. You can see that 2 where 2 here represent this 2, where this 5 represent this 5, and then the x raised to power 5 is placed outside. Why am I placing it outside? Because x raised to power 5 is common here and is common here. If you times x raised to power 5 times 2, you have this. X raised to power 5 times minus 5, you get this again. You get this. So that's for, it is easy doing it this way for those people who cannot handle the final answer at this point. So we move on. This is x raised to power 4. This is x raised to power 4. This is x raised to power 4. So what is common is x raised to power 4. I may decide to place x raised to power 4 outside, and then the coefficient, I ask myself, what is the coefficient of this minus x raised to power 4? That is minus 1. What is the coefficient of this one? That is plus 1. What is the coefficient of this one? That is plus 2. You can see that minus 1 plus 1 plus 2 are inside, are put in a bracket, while x raised to power 4 is placed outside, such that when you say x raised to power 4 times minus 1, you will get back this. X raised to power 4 times plus 1, you get back this. X raised to power 4 times plus 2, you get back this. Now let's take care of what x raised to power 3. Now there is x raised to power 3 here, there is x raised to power 3 here, there is x raised to power 3 here. So you can possibly place x raised to power 3 outside and ask yourself, what is the coefficient of this x raised to power 3? It is 3. What is the coefficient of this other one? It is plus 3. What is the coefficient of this other one? Is minus 1. And you close your bracket. If you decide to use this to multiply this, you recover it. You get back to the previous x raised to power 3. Now, the next is x raised to power 2. X raised to power 2 here is, there is x to power 2 here, there is x raised to power 2 here, and so you can possibly say x raised to power 2 in a bracket into the bracket of minus 2 minus 1. Why? Because the coefficient of this x to power 2 is minus 2, the coefficient of this x to power 2 is minus 1, and so we have to place minus 2 and minus 1 in the bracket, while the x to power 2 is outside. And then what we will have left here is 4x, because 4x is alone. So at this point, it's easy for you to say 2 minus 5. When you say 2 minus 5, every student can quickly say the answer is minus 3, because 2 minus 5 is minus 3. Minus 3 times x raised to power 5, that will give you minus 3x raised to power 5. Then you come here, minus 1 plus 1, of course it's 0. 0 plus 2, of course the answer will be plus 2. Then plus 2 times this, that will give you plus 2x raised to power 4. You now look at this one, 3 plus 3, that is 6. Minus 1, that will be what? 5. 5 times this, that will give us plus 5x raised to power 3. You come here again, this is minus 2 minus 1. Minus 2 minus 1 is minus 3. Minus 3 times this, that will give us minus 3x raised to power 2. And then 4x. This will be the final answer. I can see that minus the answer now, what the question was, find f1 plus f2 plus minus f3. So we can say that this is the same thing as f1 plus f2 minus f3. That's the final answer. Now, sometimes the examiner may say, what is the degree? Supposing this question was not asked this way. Supposing they asked us a question like, what is the degree? I've told you what degree is. Supposing the question is, I find the degree of f1 plus f2 minus f3. The question did not say, find the sum of. You just say, what is the degree of f1 plus f2 minus f3? How would you have done that? If it is an essay exam, you must do all of this. And then you now get to this point. Once you get to this point, you now ask yourself, what is the highest power? You can now see that the degree, supposing we were asked degree, the degree of this, of f1 plus f2 minus f3 would have been what? 5. Because the highest power is what? 5. This is it, 5. But you know, here the examiner did not ask for degree. The examiner asked for what? Just say, he said you should sum these two minus 3, minus f3. And this is the answer. But I'm just trying to add, supposing you are asked to find a degree. If it's an objective exam, you may not have to do all of this because it will take your time. It will take your time. How do I get it then? If it's an objective exam. If it's an objective exam, you look at the functions that are implicated or that are involved. We have this function, and this function. you now ask yourself, what is the degree of this function? The first one, the degree is 5. What is the degree of the second function? The degree is what? 4. What is the degree of the third function? Of course, the third function, the degree is what? 5. The first function is degree is 5. The second function, the degree is what? 4. The third function, the degree is what? 5. Now you can see that we have 5, 4, and 5 again. You now ask yourself, between these 3 degrees, which one is the highest? The highest is 5. And so your degree will be what? 5. Without calculating anything. But if it's an essay exam, where they say, what is the degree of this? You have to go all through this and then you get to this point. You now tell the examiner from here, the degree is 5. So we have provided answers to that question. That's the how to go about the first question, F1, F2 minus F3. So let's quickly take care of what the second question, which is F3 minus F2 plus F4. Now for the second, B, we're told to find F3 minus F2 plus F4. Okay, again, I told you whenever you see this, that this is simply a formula. Remember, in exams, it may not be expressed this way. Sometimes they can tell you, add 2x to the power 5 minus x to the power 4 plus this 2. This one. So that's another way it can be expressed. They may have to mention the function and they ask you to add it. But they can also present the question this way. So for this second question, F3 minus F2 plus F4, let's address it. Let's react to the question. Now again, we say F3. What is F3? This is F3. We bring it down, we write it down. F3 is x raised to the power 3 minus 2x raised to the power 4 plus 5x raised to the power 4. Okay? X raised to the power 3 minus 2x raised to the power 4 plus 5x raised to the power 5. Please take note, that's F3. Now minus, because it's a minus, we bring in a bracket, because this minus is to subtract everything that is in F2. Now, so what is our F2? F2 is 4x minus x raised to the power 2 plus 3, x raised to the power 3 plus x raised to the power 4. You close your bracket. You can see that the minus sign here tells you that the minus sign is to subtract everything here. So if you do not indicate your bracket, it will look as if the minus sign is subtracting only the first term of what? F2. So now I haven't written the second term, which is F2. The formula says plus. So we bring in the plus sign, and then the next is F4. F4 is 2x minus x raised to the power 2 plus 2x raised to the power 3. That is F4. Now, having done this, the next thing is to remove this bracket. If I'm removing this bracket, let me bring this one down. That will be what? X raised to the power 3 minus 2 x raised to the power 4 plus 5x raised to the power 5. Now, we have to remove the bracket. That means minus will multiply everything here. So minus times this, of course, that will give us minus 4x. Minus times this will give us plus x raised to the power 2. Anytime minus multiplies another minus, the answer will turn to what? A plus. So minus times minus, that will give us plus s squared. Minus times plus. Anytime minus multiplies a plus sign, the answer turns to what? Minus. So minus times plus, that will give us minus 3x raised to the power 3. Minus times this will give us minus x raised to the power 4. Now, I've used this minus to multiply everything here. The next thing is to bring a plus sign. I'm supposed to use this plus sign to multiply everything also that is in F4. But you know that plus times this will remain this, plus times this will remain this, plus times this will remain this. So it's as good as bringing down plus 2x minus x squared plus 2x raised to the power 3. So this is where we are. This is where we are. So at this point, like I told you, you have to select like terms. You have to select like terms. And as you're selecting like terms, have it in mind that you select in line with what? An order of what degrees. It's either you start with the highest term or you start with what? The lowest. So if I'm starting this, the other one again, I start with the highest term, the term with the highest degree. So this time I will want to start with the term with the lowest degree. Now, if I have to do so, the lowest degree here will be 1. Of course, it has to be 1. Let's see, there is 1 here. X minus 4x raised to power 1. That's the lowest degree. Okay, there is another one here. So I will bring those ones down. I'll bring them down. So I will begin with this one. I will say minus 4x. I'll bring this one plus 2x. Remember, 4x that's a degree of 1. This one has a degree of 1. This has a degree of 1. I think that's all. After degree of 1, it has to be degree 2. Now, which are the terms with the degree 2? You see that we have here, that is x raised to power 2. This is x raised to power 2. Do we have another? There is another here. That is minus x raised to power 2. After power 2, the next is power 3. There is one here. Now, you see here now, the x raised to power 3 is at the front as the first term here. And at this point, the plus sign we didn't show this plus sign. At this point now, I'm going to show it because it's going to be in the middle. So bringing this one, it becomes plus x raised to power 3. And then the next, another s raised to power 3, we have another one here, minus 3x raised to power 3. Do we have another? There is another here. That will be plus 2x raised to power 3. Remember that as you're bringing them with their sign. This sign is plus, so I bring in the plus. This sign is minus. I have to bring this s raised to power 3 alongside its own sign. Remember that when you have terms written like this, the sign in front of any term belongs to that term. Please take note. Okay. Now, having done so, x raised to power 3, the next has to be x raised to power 4. What are they? This is the first one, minus 2x raised to power 4. Do we have another? This is another one, minus x raised to power 4. I think that's all. And then the next is x raised to power 5. This is x raised to power 5. We bring that plus 5x raised to power 5. Is that all? Now let's count to be sure that we have represented or we have taken all the terms. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are right. Okay, we are correct. At this point, we have selected the line terms. So what we need to do now is to factorize. Now, what it means is that we look at now, let's factorize as we did the other time. Now, for minus 4x plus 2x, what is common between these two terms is what? The x. The x is common to both. So what we do, we have to say my x is outside the bracket, while the coefficient of this x is minus 4, the coefficient of this x is plus 2, we place the coefficient inside. Now I take that again. The coefficient of this x is minus 4, it has to be inside the bracket. While the coefficient of this x is plus 2, it's placed inside the bracket. While what is common to both of them is x, that x should be placed outside. That's what we mean by factorization. So I will equally factorize s squared. Now, for s squared, when you look at s squared, what is common between, for this term, that term, s squared is common here, s squared is common here. So I will place s squared outside the bracket, and I will now ask myself, what is the coefficient of this s squared? That is 1. What is the coefficient of this x? That's minus 1. And then you place 1 minus 1 inside the bracket, and then the s squared is outside the bracket. When you do that, you have factorized s squared. Then let's take care of what x raised to power 3. For x raised to power 3, again, what is common to this term, and to this term? You know that it is x raised to power 3. I will now say x raised to power 3 into, what is the coefficient of this x raised to power 3? The coefficient is what? 1. The coefficient of this one is minus 3. The coefficient of this one is plus 2. Therefore, it means that 1 minus 3 plus 2 must be inside the bracket, while the x raised to power 3 has to be outside the bracket, because that is what is common to those three terms. Now, let's take care of x raised to power 4. For x raised to power 4, what is common here? Again, you see, these two, what is common to both of them is x raised to power 4. Therefore, we say x raised to power 4 outside, while the coefficient of this one is minus 2, the coefficient of this one is minus 1. Therefore, it means that minus 2 and minus 1 are inside the bracket, while the x raised to power 4 is outside the bracket, because it is common to the 2 minus 2 and minus 1. Then finally, we're going to have what? 5x raised to the power 5. So at this point, it's easy for you to manipulate. You can go ahead to say minus 4 plus 2. Of course, the answer will be minus 2. Minus 2 times x, that is outside. Of course, our x standing outside means it is multiplying the content of that bracket. Therefore, we say minus 4 plus 2. The answer is minus 2. Minus 2 times x, that will give us minus 2 what? X. We come here again. 1 minus 1 is 0. And that 0 times x squared is 0. That means x squared will no longer exist in this expression. What that implies that x squared disappears. So I will not represent it here. If you chose to represent it, it will be represented in the form of 0 x raised to the power 2. It's as good as not representing it. So we can forget x raised to the power 2 because it's already 0. Now you come here. 1 minus 3. 1 minus 3 is minus 2. Minus 2 plus 2, the answer is 0. 0 times x raised to the power 3, it is 0. We come to this one, minus 2 minus 1, the answer is minus 3. Minus 3 times x raised to the power 4, that will give us minus 3 x raised to the power 4. And then you bring down plus 5 x to the power 5. You can see that this is the final answer. And this is equal to the F3 minus F2 plus F raised to F4. So this is the final answer. Now, supposing the question was, supposing the question demand that we should look for the degree of F3 minus F2 plus F4. It means that you will simply, at this point, you will simply say the answer is 5. Now, degree, remember, this was not asked. Degree of F3 minus F2 plus F4 is equal to what? 5. I told you that if it's an objective exam, you don't need to do all of this because it will take your time. What do you do in that case? Just ask yourself, what is the degree of the F3? Go through F3, the degree, the highest power is 5. You say 5. F1 degree, F3 degree is 5. You ask yourself, what is the degree of the second, this F2? You go through, the highest power is 4. The degree of what? The degree is 4 for F2. What is the degree of what? The F4. The F4, the degree is F4. You see that the degree is, what's the degree? The degree is 3. 3. And that's what F4. You can now say, what is the highest between 5, 4, 3? Which is highest? You see that 5 is what? The highest. Therefore, the answer is 5. Without actually doing all of this. But if it's an examination that demands you to show how you arrive at that 5. For example, if it's an essay exam and you're asked, find the degree of F3 minus F2 plus F4. And you think it's because you can do it this way. And you do it this way, right? You must have failed. But what you do in that case is you will have to show this. Start from the way we have done it to this very end. You cannot say, therefore, the degree is 5. Again, if the examiner did not say, find the degree of this, the examiner just say, find the degree of the second term of F3 minus F2 plus F4. Look at the question. What is the degree of the second term of the expression F3 minus F2 plus F4 given? They've given F1, F2, F4. In a case like that, you may not use this method. What you need to do is to show this till you get to the final answer. And once you get to the final answer, you ask yourself, which is the second term? Of course, this is the second term. The answer will therefore be 4. Now, let's take the final answer, the final question. Our final question is C. F4 times F3 minus F2 plus F4. Remember, we've already gotten what? The answer, which is this one. This answer is what? The whole of this represents this answer. So we will use this answer we use F4 to multiply this answer. That's what the question requires us to do. So let's quickly do that. So here we have F4 into F3 minus F2 plus F1. And this, of course, is equal to. Remember, we said that this is a formula that is telling us that we should use F4 to multiply this answer. We now ask ourselves, what is F4? F4 was given to us as, this is our F4. 2x minus x squared plus 2x raised to the power 3. That is for F4. We are asked to use this F4 to multiply F3 minus F2 plus F1 plus F4. So, of course, we've gotten that as the answer. This is the answer. We'll now open a bracket and then write that there. This is our answer, minus 2x minus 2x minus 3x raised to power 4 plus 5x raised to power 5. So what we need to do here is to multiply. Just use this that is outside, what is outside, to multiply what is inside the bracket. What this means is we will take each of these terms. Of course, you know that this is multiplication of our polynomial. So I will take, you know that F4 has 3 terms. This one has 3 terms. So for each, you will use each of these terms of F4 to multiply what is inside there. So what that means is that I will use 2x into minus 2x minus 3x raised to power 4 plus 5x raised to power 5. I'll close the bracket. It means first I will use this one into this. I haven't done so. I will now go for the second term. The second term of what? Minus s squared. The second term of what? F4, which of course this is F4. Minus s squared. Minus s squared into minus 2x minus 3x raised to power 4 plus 5x raised to power 5. You close the bracket. You go again. You take the third term, which is 2x raised to power 3 into minus 2x minus 3x raised to power 4 plus 5x raised to power 5. At this point, you now multiply. Now you now say 2x times minus 2x. Here now, the first law of indices must be involved. The first law of indices. So we are saying that, look at what we are doing here. 2x times minus 2x. Remember that this is the same thing as 2 times x times minus 2 times x. What you do here is simply, for those who may be confused, 2 will multiply minus 2 there. That will give you minus 4. Then the x times x will give you what? X squared. What we have done for the x is that, remember indices, because that's what you apply to all of them. Now indices, this x is raised to power 1, this x is raised to power 1. So you take only one of the x, the powers are added. It becomes 1 plus 1. So that will be minus 4x raised to power 2. So 2x times this will give us minus 4x to the power of what? 2. 2x times this, again, this 2 will times the 3, that will be minus 6. Then x, take note, this 4 plus 1 here, there is 1 here that you have not seen. First law of indices, that will be what? X raised to power. This 4 plus that will be 5. 5. I take that again. X raised to power 4. This 4 plus 1 here, that will give us x raised to power 5. Then this 2 will multiply minus 3. That will give you minus 6 there. Then again, 2x times 5x raised to power 5. Again, this 2 will multiply the 5. That will give us plus 10. Then x, 5 plus 1, that will give us 6. We are done with this bracket. Let's take care of the second bracket. Now here, there is an invisible one here. There is 1 here, minus 1. Minus 1 times minus 2, that will give us plus 2. That will give us plus 2. Then x, 2 plus this 1, that will give us 3. That is to say, minus x squared times minus 2x. The answer should be plus 2x raised to power 3. This again will multiply this. Minus 1 will multiply minus 3. That will give us plus 3. Because the minus will cancel. Minus times minus will be a plus. That's why it is plus. Then there is 1 there. 1 times this 3 will give us plus 3. That's why we say minus 1 times minus 3, it will give us plus 3. Now for the x, what happens to the x? This x raised to power 2 will multiply x raised to power 4. Remember, first law of indices, it becomes 2 plus 4. That will give us what? 6. That will give us 6. Then minus x squared times this, that will give us minus 5. Remember again, there is an invisible one there. That minus 1 times this plus 5, that is minus 5. What happens to the x? That will be x. Remember there is 2 here. This 2x squared times x raised to power 5. That is simply by saying 2 plus 5. That will be what? 10. So you're going to have minus 5 raised to power what? 10. We are done with this bracket. We now go for the third bracket. Now this 2 minus, this is 2x raised to power 3 times minus 2x. Again, this is 2 times minus 2, that will give us minus 4. Then x, remember, this is x raised to power 3, and it's multiplying x raised to power 1. Simply say 3 plus 1, that will give us x raised to power 4. We come here again, 2 times this, that will be minus 6, x. 3 plus this, that will be what? 7. This 2 times this is minus 6, 3 plus this, that is 7. Then 2 times this is plus 10. Then x, 3 plus that will be what? 8. So at this point, what do? At this point, we have to select like terms. We have to select like terms. Again, you may start with the power, the highest power. You may decide to start with what? The lowest power. Remember that it has to be so because you want your answer to be either in ascending order of degrees or descending order of what? Degrees. So I want to start with the highest power. Let me start with the highest power. I will look through all. Which of the terms that has the highest power? You can see we have power 10 here. We have power 8 here. Okay, power 10 is the highest. So I'll bring down the power 10. The power 10 has a minus sign in front of it. So I will say minus 5x raised to power what? 10. You can see how the minus sign belongs to this term. So I brought it down with a minus sign. After this term, which other term has the higher? No, there is no other term with the power 10. After power 10, what other term do we have? It's power 8. Yes, after power 10, the next is power 8. And this is the term that has power 8. We bring it down. So we now say this is plus. Of course, there is a plus sign there. Plus 10 x raised to power 8. After power 8, which of the 10 that should come next is power 7. Power 7. Remember, we are doing it in order of what? Decreasing power. Decreasing degree. After power 8, the next should be what? Power 7. And this is power 7. Do we have another? There is no other power 7. So we'll bring this one. That is minus 6 x raised to power 7. After my power 7, what other power do we have? Power 6. We have power 6 here. So we have plus 3 x raised to power 6. Do we have another? Yes, there is plus 10 x raised to power 6. I think these are the only two that we have for power 6. After power 6, what else? Power 5. Power 5. Power 5. We have one of the power 5 here. This is it. I think that's all. Minus 6 x raised to power 5. We have power 5. The power of 5 only one. Minus 6 x raised to power 5. After power 5, what else do we have? What else do we have? We have power. Do we have power 4? There is power 4. How many of the power 4 do we have? Just this one. So we have minus 4 x raised to power 4. After power 4, what power? Power 3. How many do we have? We have only this. This is only power 3. We bring it down. Now plus 2 x raised to power 3. After power 3, which other power do we have? Power 2. Power 2 is next. And power 2 is minus 4x squared. We bring it minus 4x squared. Do we have another? There is no other x squared. There is no other. No. You see, these are the only ones we have. Let's confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are okay. We are right. So we've taken the number of terms here are equal to the number of terms that are originally present here. So at this point, what do we do? Again, we try to further take this to the final answer. Minus 5x raised to power 10. We have only one with only it. We bring it down. Minus 5x raised to power 10. 8 here, it's alone. 10 raised to power 8. Okay. Then when it comes to this is alone. Minus 6x raised to power 7 is alone. How about this one? How about this one? This is now 3x, 10x. 3 plus 10. Of course, that will give us what? 13. That will give us plus 13 x raised to power what? 6. We come to x raised to power 5. We come to x to the power 5. This is x raised to power 5. X raised to power 5 is alone. So we'll bring it down. Minus 6 x raised to power 5. Then we come to x raised to power 4. X raised to power 4 is equally alone. This is minus 4 x raised to power 4. Then we have here plus 2 x raised to power 3 minus 4 x raised to power 2. So this is the final answer. And this is what we call, this is the same as, this is what we call F4 into F3 minus F2 plus F1 is equal to this. So this is the final answer. So this is all. I think that this is enough for you to have understanding when it comes to addition, subtraction, and multiplication of polynomial. Like I told you, one video, one lecture is not enough, because we have what other subtopics for polynomial. We have addition, degree. Okay, we have degree of polynomial, addition, subtraction, multiplication. That I have done in this video. We also have division. We have division. We have factorization. And now you find that in other videos of mine. I have done those videos. I'll even drop a link for those videos. So please, if you have watched this video, look for the other ones for you to have 100% understanding of polynomial. I want to believe I have made this as simple as possible. In case you have any question, in case you have any need, please go to the comment section and drop. I will respond urgently. And again, don't fail to hit the subscription button. Do not also fail to turn on your notification button, so that when new videos are made, you'll be first to be notified. Again, please share and like the video. Thank you.